This unit, Unit 3, introduces the concepts of congruent parts of congruent triangles. The entire unit is about triangles. Now, first off, ignore the top. Week 5 doesn't matter. All right, we're going to begin with congruency markers. So I'm going to write the word, say congruency markers. I've told you before, drawing pictures in geometry really helps. They don't have to be perfect, but they help. This line is a congruency marker, as is this arch. So when you see one line through a side and one line through a side on a different figure, that says that both of those sides are congruent to each other. We call them congruency markers. Same with this. Look at angle Z and angle A. They both have 3 lines on them, correct? That shows you that those 2 angles are congruent to each other. Why do they have 3 lines? Well, I'm going to answer that question as we do this exercise. It'll make sense. So we're going to name the congruent angles. Angle A is congruent to angle Z. Why? They have the same number of congruency markers. Angle A has 3, angle Z has 3. Keeping that in mind, angle B is congruent to angle X because they both have 1 congruency marker. Angle C is congruent to angle Y. They both have 2. They have different numbers of congruency lines because they are all different measures. Angle B is not congruent to angle A or angle C. All 3 of them have different measures. But angle B is congruent to angle X because they both have 1 congruency marker. Now let's look at sides. The same concept goes with triangle sides, except we don't use little arcs, we use dashes. Side AB, and I'm going to use a highlighter. See, side AB has 2 congruency markers. So I'm looking for the other side that has 2 congruency markers. And that would be ZX. Why am I not calling it XZ? I am focusing on matching the parts. We start with A. A has 3. We'll start with the congruent angle Z. So I'm going to go over here and I'm going to call this side, side ZX. And then AC has 1. It's congruent to side ZY. BC is congruent to side XY. And here we're going to name our triangles. Be careful how you name your triangle. Order does matter. What you're doing is you're matching the congruent angles. So, in triangle CBA, which angle matches with angle C? That's angle Y. Which angle matches with B? That's X. And which angle matches with A? That's Z. The order does matter because you're saying this triangle with these particular angles is congruent to that triangle because those angles all match. They're all congruent. So let me show you. I'm just going to play around just a little bit. Triangle CBA. And if you notice, if I do triangle XYZ, does angle C correspond to angle X? Is angle C congruent to angle X? Look at the congruency markers. No, not congruent. That's why you have to match using the congruency markers. All right, now we're going to talk about pieces that are congruent. Sides and angles. They are the pieces. They are the items. Okay, let's look at these triangles. There's our congruency symbol. You learned that in Unit 1 and Unit 2. Here we have, notice, 1, 2, 3 sides are congruent. So these 2 triangles are congruent because side, side, and side are congruent. All three sides are in one triangle are congruent to the corresponding three sides in the other triangle. So now we're going to look at another one. We have, if you look, you know they're congruent because we tell you they're congruent. And you have a side, then a congruent angle, then a congruent side. They are congruent by side, angle, side. Nothing fancy, nothing secret. We're actually using the initials of what we see. Let's look at the next one. We know they're congruent. We start with an angle, then the next congruent piece is a side, then an angle. See, they go in a line. We're going to go, hang on. We're going to go that way. Both triangles, side, angle, side. Honestly, I could go this way too. Okay, here we went that way on both triangles. We could go this way. It's still the same thing. Now let's look at this one. Okay, do you see where I'm going with that? Okay. Let's look at here, and I'm gonna start up here. I have an angle, and I have a side. My side is not between the two angles, is it? Angle, angle, side. Now you could say side angle, angle. It's not incorrect, but you're not going to see a congruency property called side angle, angle. So I'm going to write a little note here. SAA is the same as AAS. Side angle, angle is the same as angle, angle, side. So if I went the opposite direction, I would still get there and it would still be mathematically correct. Now, when we get down to right triangles, it's a teeny bit different. Now, you know, there's your right triangle. They have the right angle indicator. Right triangles have special parts. This is called, let's do it, and I'll do it in green. That's a hypotenuse, isn't it? The side opposite the right angle. The other two sides are called legs. Whoops, leg. So they are congruent by the hypotenuse leg. We don't have to have 3 letters in this one because it's a right triangle. So we already know they have one angle congruent. So when you see a right triangle, it is not angle, side, side, because this is one of my little favorite sayings, and you're going to laugh, and yes, I'm putting it on YouTube. There is no ASS in geometry. True, there is no angle, side, side in geometry. I'm going to say it a lot. Now let's look at this last one. You notice we have 2 congruency pieces. I'm going to highlight them for you. You have this side. The sides are congruent and the angles are congruent. But if you notice, if you're trying to make a connection, we don't know the measure of the third side. You cannot say, excuse me, I'm tripping over myself. You cannot say a triangle is congruent to another one with only 2 pieces of congruency information. You must have 3 pieces. So, angle, angle side is not sufficient for congruency. Neither is side angle. Must have 3 pieces. So let's look back just at these 6 triangles, okay? Notice in the side, we had 3 pieces of congruency information. 3 parts of the triangle were congruent to 3 other parts of the triangle. And actually, let me erase this. And this should actually be angle, side, side. Angle, side, side. See how angle, side, side? Which is what I said, there is no ass in geometry. There you go. Going back up to the top. Those three sides are congruent. We have three solid congruency pieces. Here, side, angle, side, we have three solid congruency pieces. We do for each triangle, even down here in the right triangle. We don't say the right angles are congruent, but we know they're congruent because they're both right angles. We have three pieces. But here, angle, side, side is not enough. I can move that second side all over the place because I have no idea what this angle is, what the angle between side 6 and 11 are. So I cannot say with definitely that those two triangles are congruent. So when we say over here, if you can create one triangle congruent to the given, those triangles must be congruent. What we mean is this. This will be an exercise in Alex. You're going to play around with creating triangles. You're going to move one side. You're going to be able to do that. If you can move it anywhere and connect in a couple of places, then you're making more than one triangle. So angle, side, side is not enough to prove congruency. Again, there is no ass in geometry. All right, let that one sink in. Doing a lesson is going to help a lot. Let's go to the next page. Okay, proving triangles are congruent. Now this is where we're going to do some writing. Side, side, side says if three sides of one triangle are congruent to three sides of another, the two triangles are congruent. Okay, let's look at this. Well, we can probably say, and we're playing with this, guys. We can probably say, I'm telling you now, those two sides are congruent. That's the first side. But I don't have any other congruent sides. Only one side is congruent. So I can't say that these two triangles are congruent. Now, I've told you before in geometry, you cannot assume that what you see is actually true. We have to tell you that is true, or you prove it mathematically. So I'm telling you right now, those two sides are congruent. I haven't measured them. I'm just telling you. So you assume it's true. But look at the others. They are not congruent. So we cannot say side, by side, 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 those triangles are congruent. Now let's look at side, angle, side. If two sides and an angle of one triangle are equal to two sides and an angle, then the triangles are congruent. And let me give you something. The angle must be between the sides. So let's do it. This side's congruent to this side, and this side's, two congruency markers, this is congruent to this side. See, I'm not saying they're the same, I'm saying they're congruent, and then this is congruent to this, side, angle, side. I'm not saying that my one marker is congruent to the side with two markers. I'm saying my side with one marker is congruent to the other triangle with the side with one marker. I'm sorry if I'm confusing you with words. Okay, angle, side, angle. I'm going to do that one. If two angles and the included side. Included side means side between the angles. Okay, so I'm going to say that side's congruent to that side. Oops. And then this angle's congruent to this angle. Yeah, I'm messing with your heads right now. And this angle is congruent to this angle by angle, side, angle. two angles and the side between. That's ASA. Up here, it's two sides and the angle between. See the difference? In the green, two sides with the angle in between are congruent. Those three little pieces together. Triangles with the red, two angles with a side in between. Okay, next page is more congruency pieces. Congruency properties. All right. Now, angle, angle, side. Now we're talking about let's do that in blue. Non-included side. That means a side not between the angles. Side not between the angles. So I'm going to say this angle is congruent to this angle. This angle is congruent to this angle. And this side's congruent to this side. Okay, angle, angle, side. The sides are not between the angles. Last congruency property. There are 5. The last one we're going to do is hypotenuse leg. The important thing here is the parts of a right triangle, because we already know the angle's congruent because they're both right triangles. So the hypotenuse would be here and a leg. It doesn't matter if it's the short leg, the long leg, doesn't matter, but it has to be the same leg on both triangles. So that triangle is congruent by hypotenuse leg. Now the next couple of exercises are going to help you practice using the congruency properties, using, as you see listed, side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. They don't have any fancy names. We don't call them theorem 3.1 or anything like that. We call them what they are. We call them by the pieces that are congruent. All right, let's look at these two triangles where it says congruent or not. Okay, well, we have a side, an angle, a side, an angle, and a side, and the angle's between the two sides. We have a side, an angle, and a side. So they are congruent. Well, they're not right triangles, so you can mark out hypotenuse leg. We only have one angle in there, so you can get rid of angle, angle, side, and angle, side, angle. And we do have an angle. We don't have 3 sides, so you can get rid of side, side, side. So it's side, angle, side. They are congruent because we saw the congruent pieces are in the same places. We call that corresponding. We'll get to that. They're in the same places. And then we eliminated what could not work. All right, let's do the next one over here. Same concepts. Determine whether the triangles are congruent. If they are, which postulate, old-fashioned word, we don't use them anymore, why they are congruent. Okay, we have an angle and an angle. We have a side beside the angle. Then we have an angle and angle. So we have, do we know if it's a right triangle? No. We have an angle, side, angle, and on the corresponding parts, the same place as on the other triangle, we have an angle, side, angle, so they are congruent. And it's by angle, side, angle. Because we didn't have 3 sides, and we had 2 angles. And this time, the side was between the 2 angles, angle, side, angle. You call it by the congruent parts. Angle, side, angle. Nothing fancy there. Let's go to page 4. Now, we're going to put some more in here. This is where you, again, have to apply. Remember, you did this with linear pairs and vertical angles. You had to remember that linear pairs added up to 180 and that vertical angles are congruent. So here, You look here, there may not seem to be enough information to say the triangles are congruent, but there is enough information. I'm going to highlight some things for you. Okay, so reflexive. Look for sides that your triangles share, make them congruent. So we have a congruent angle there, and then we have, a congruent angle here. And look, NQ is shared by triangle NQM. I guess we'll have to use another highlighter. NQM and NQP. They have the same side. Well, of course, the same side is going to be congruent to each other. So I'm going to put a little mark right there. So now we're going to label the pieces that are congruent. We have an angle, and then we have a side, but is the side between the two angles that are congruent? No, it is not. So this is going to be angle, angle, side. Whoops, there we go. Because NQ is not between the yellow angle and the green angle. So it is angle, angle, side. So I'm going to label my triangles. Now remember, I told you how it makes a difference. I'm going to give the correct names. You can start with any vertex you want on a triangle, but just make sure that you use the corresponding part. I'm going to start with M. So triangle MNQ is congruent to, well, angle P is congruent to angle M, then angle N, then angle Q. You could call it triangle NMQ, then that would be, that would be N, boy, I'm getting all tripped up here. I tell you, making this harder than it has to be. And PQ, or you could say triangle, QNM. And that would be triangle QNP. You could also, you could do QPN, whatever. So my point is, the congruent parts of the triangle have to match up. We call this corresponding. Angle M corresponds to angle P. They are both congruent. They have two congruency markers. Angle M and Q corresponds to angle P and Q. Alrighty. I know, lots of major concepts here. Let's look at the next side, vertical angles. Now remember what you learned. Vertical angles are congruent. So, I'm about 1,000 a day. Those two are congruent. They're vertical angles. So vertical angles are congruent. We didn't have to tell you that because you should be remembering this from Unit 2. So now we have an angle, a side, and an angle. So we know angle, side, angle. Let's give them names. I'm going to say ABC. Why not? Now, there's no congruency marker on A. There's none on E either. So I'm going to start with E, then B, then C. Make sure my parts correspond. You may want to stop the video at this point, look back, print this if you can, make marks all over it, make notes to yourself. All right, page 5. Now we're going to do this with Alex. We're going to apply. You've got 5 congruency principles, and we're going to give you some notes that you can actually use on the test. But use your notes to do these. So let's take a look at what we know. Remember I said corresponding parts? I used that term. Let's see. Corresponding parts are congruent in each triangle. So let's take a look at this. You're going to have to determine on this exercise if they are congruent or not necessarily. And not necessarily means you don't have enough information. You cannot say, yes, they are. I only have 2 pieces of congruency information. If they're congruent, you have to give them the correct name and the property. So let's take a look. In triangle, let's do triangle MNO, you have a side, an angle, then a side. But in triangle RPQ, you have a side and an angle, and the side's on the other side of the triangle. So they are not necessarily congruent because the sides do not correspond. Congruent needs triangle in the same place. So we don't know if they're congruent. And if they're not necessarily congruent, there's nothing else you have to do with that particular problem. So let's look at B, different color. You have a side, an angle, and a side, and you have a side, an angle, and a side. So they are congruent. We know. Now, in the choose one, you're going to have a drop-down menu, and you're going to choose side, angle, side. So now we have to name them. This triangle is UVW. So triangle U, so this is where it gets tricky, guys. Pay attention. UV has 2 congruency markers. And so this will be X, Y, Z. X, Y, Z. Alrighty? I had to follow along. Angle V had the 1 congruency marker, so it corresponds with angle Y, and that's the second letter. You just have to look carefully. If you get something wrong, you'll probably get the name wrong. You just have to look carefully and go slowly. It is important to understand corresponding parts. I'm going to put over here. Angle U corresponds to angle, what did I say, X, and UV, that really is a U, side UV corresponds to side XY. Alrighty, I know it's a big one. Let's look at C. Now we only have 2 pieces of congruency information. You see that? We have this angle and this side, but those are vertical angles. So we know they're congruent to each other. So we can say these are congruent by the angle, side, angle. And this is triangle ABC, and so this one would be triangle EBD. Now the last part are proofs. Now if anybody ever watched Star Trek, you guys are too young. You gotta watch the old Star Trek, where Spock would say it's only logical. Geometry proofs are saying, I know this is true and this is why. Not it looks like it, but a mathematical reason. When you start a geometry proof, we call this a 2-column proof, everybody's favorite. Just ask any math teacher. 2-column proof. You have your statement side on the left, which is, I'm saying these 2 things are congruent. The reason on the right is your legitimate mathematical reason. You'll never see, because I said so. That's not a legitimate reason. Now your proofs always start with something. they start with what's called the given information. Remember I told you at the beginning of geometry, you cannot assume anything we tell you. It may look congruent, but we have to tell you. The given information is that ST is congruent to UT. So what you should do, draw the same figure on your paper. Just draw it. Make marks. We are given that ST is congruent to UT. So I'm going to put congruency lines there. We are given that RS is congruent to RU. RS is congruent to RU. You have to prove that RST is congruent to RUT. So we put in always on your statement side, you list the given statement because those are mathematical facts. You put them down. So ST is congruent to, and you're going to fill in the answer, UT. And the reasoning is given. That is legitimate mathematical reasoning. Now, the next statement is RS is congruent to RU. The reason? This is where you have to choose the reason from a drop-down menu. The reason, well, it's also given. Now, there is nothing we have with the angles, but if you go back to page 4, I think it is, on these notes, possibly 3, you can look, remember we said about triangles that share a side? The shared side is always congruent, so RT is congruent to RT because it's congruent to itself, and that is the reflexive property. Something is congruent to itself by the reflexive property. So look at your picture. How many pieces of congruency information do we have for each triangle? We have 3. Need 3 pieces of congruency info. We have 3 pieces, so now we can say the triangles are congruent. And the reason? Side, side, side. This is called a proof. You just proved mathematically that those 2 triangles are congruent. You used the information we gave you, and then you used information you knew that was mathematically sound. Okay, let's go to the next one. All right, now we are going to write this proof. In Alex, you're going to type in everything and you'll still have the drop-down menu for the reasons. So, the step 1, put in your givens. I'm going to add step 1A. I'm going to add a step. Step 1A, draw the figure and put in the congruency markers. It really does make things easier. Instead of trying to visualize it without marking on it, draw the figure, whether you do it on a whiteboard, desk, or paper, draw it, put in the markings. It really does help guide you as to where you're going to go. Alrighty, so let's do this. I'm going to mark first. Given BC is congruent to DC. BC is congruent to DC. So I'm going to say BC is congruent to DC. My reason? It's given. And there actually will be a line going down these there. And if you take more steps, you take more steps, no big deal. Okay, my second given, AC is congruent to EC. I'm going to AC, I'm going to mark that. Now I'm going to write it. That's also given. Now, I've got to think, I've got to apply everything I know. Okay, that's a bow tie. Ooh, I remember something. Bow ties have vertical angles. So that means this angle is congruent to this angle. So angle ECD is congruent to angle ACB. This is why you had to learn how to name angles. The vertex goes in the middle. You learn this the very first unit. And my reason, vertical angles. Because they are vertical angles, therefore they are congruent. A mathematical fact. Now, do I have 3 pieces of congruency information? I do. So I need to prove triangle ABC is congruent to triangle EDC. Whoops, EDDC. I added another letter. The reasoning? Well, remember, we call it like we see it. We see a side, then an angle in between, then a side, angle, side. And that's what you do. I really hope you are watching all this. We'll do some stuff in class, and I will always be there to help.